Students, here we are going to discuss a problem on the set domain transfer function from the S domain transfer function. It is a university question asked in the KTU examination. Here we are asked to find the set domain transfer function from the S domain transfer function. So the question is, determine the set domain transfer function for the S domain transfer function h of s equal to a by s plus a whole square. So here h of s is given, that means Laplace transform of impulse function is given, that is h of s is equal to a by s plus a whole square. So we want to find out set domain transfer function from this h of s. So we know that there are three steps to find h of z from h of s. First step is we have to find out h of t, that is obtained by taking the inverse Laplace transform of h of s. In the second step we will put t equal to kt, and in the third step we will find a set transform. That is three steps. So let us see. First of all, we can write h of s is equal to a by s plus a whole square. So from this this is a Laplace transform of h of t. So from this we can find h of t by taking the inverse Laplace transform of this h of s. So h of t equal to L inverse of h of s. So this is in the form of a by s square, but s is displaced by a. So what is its meaning? See, 1 by s square Laplace transform, it is a Laplace transform of t, but here s is displaced by plus a, that means e raised to at. There is a shift in this, that means there is a term e raised to minus at. So a is a constant, so we can write the inverse Laplace transform of 1 by s plus a whole square is equal to t into e raised to minus at. So this is the h of t. Okay, so first step is completed, that is h of t is obtained by taking the inverse Laplace transform of h of s. So that is equal to at into e raised to minus at. In the second step we will put t equal to kt, that is we will find h of kt, that is obtained by letting t equal to kt. So h of kt can be obtained by, what is, instead of t we can put kt, that is equal to a into kt into e raised to minus akt. So this is our function. In this a and t are constant. The function is k into e raised to minus akt. So we have to find out in the third step we have to find out the set transform of this h of kt. Okay, so that is our question, set domain transfer function. So to find the set transform of this function, that is will be equal to h of z, that is equal to z of h of kt. So here you can say that a and t are constants, k into e raised to minus akt is a function. So it is in the form of k into f of k. So let f of k is this quantity e raised to minus akt. So we have a general formula k into f of k, the set transform of k into f of k. See here, the set transform of k into f of k will have a form minus z into d by dz of f of z. So f of z is the set transform of f of k. So if quantity k is multiplied to f of k, so the set transform equation will be minus z into d by dz of f of z. So here actually this term is a product of two functions, k and e raised to minus akt. Here we are taking e raised to minus akt as f of k. Let it be f of k equal to e raised to minus akt. Let us find the z transform of this f of k. So f of z will be equal to z transform of f of k. E raised to minus akt will have the z transform. We have it from the set transform equation, that is f of z will be equal to sigma k equal to 0 to infinity f of k into z raised to minus k. That is equation for set transform, one sided set transform. So instead of f of k we can substitute this quantity. So we will be getting sigma k equal to 0 to infinity e raised to minus akt into z raised to minus k. Here you can take a k outside, so this will be like this. So it is in the form of a geometric sum series expansion form, that is it is in the form of sigma k equal to 0 to infinity c raised to k. We have the equation k equal to 0 to infinity c raised to k will have the equation value will be equal to 1 minus c if c mod c less than 1. Here you can find that this is in the form of c, so it is in the form of c raised to k. Here c is less than 1, so we can write it as a 1 by 1 minus c, that is 1 by 1 minus c. Instead of c you can put e raised to minus at z inverse. So this is infinity geometric series sum formula. So now we have f of z will be equal to this quantity. So our function is in the form of k into f of k form. see this is k into f of k form. F of k is this quantity. So f of z we have found out this f of k. So f of z will be equal to, now we have from the above calculation, f of z equal to 1 by 1 minus e raised to minus at by z. See, z inverse can be written as by z, that will be equal to z by z minus e raised to minus at. So remember this one, okay. So next, by the property of the Z transform, we want to find out Z equal to Z transform of k into f of k. So that have the equation minus Z into d by dz of f of z. F of z we have obtained. So let us substitute that f of z instead of that f of z here, that is written here. So this we can find out the first derivative of this term. So denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. That is our equation. So minus z will be there, and the first derivative of this one will be written like this. So this is the denominator into derivative of numerator is 1 minus the numerator into derivative of denominator is equal to z. Okay. No, the derivative of denominator is equal to 1. Okay. So divided by denominator square, that is given here. So this can be written as like this. Okay, z into e raised to minus, here common term will be cancelled out and we will obtain the final equation like this. Okay, so we can write h of z is equal to at into z transform k into e raised to minus akt. We obtained that relation from here. Okay, here h of z is equal to z transform h of kt, that equal to z transform of ak into t into e raised to minus akt, that equal to at into z of k e raised to minus at. Actually we find out this equation. Now we have to multiply this equation with at in order to obtain h of z. Okay, so finally we can write h of z will be equal to at into this equation. So here we obtained this quantity, so we can put it there. So final value of h of z will be equal to at into z into e raised to minus at by z minus e raised to minus at whole square. So this is the way to find the z transform from the S domain transfer function. So in order to find it out, we have to know the inverse Laplace transform, and also we know the calculation for Z transform. So that's all about this problem. Thank you.